Okay, here's the next few examples for section 4.1. We're going to start with example number 1. So I've given you a picture here, and it asks us for each of the numbers a through e, state whether the function has a local minimum or maximum there, an absolute minimum or maximum there, or is it neither? And so I would like you to pause the video. I would like you to go through those 1, 2, 3, 4, 5, 6 different points, and I would like you to think about if you think that's a relative or local min or max, an absolute min or max, or neither. Okay, for f of a, the first point, it's an endpoint, and is he the lowest point there ever is? I actually called that an absolute minimum because I noticed that he was the lowest point on that interval for this graph. I didn't call him a relative minimum because a relative minimum would mean that would go down and come back up, and I don't really know what's happening on the other side of that. So I don't know that he's a relative or local minimum, but I do know he is the lowest value, so I can for sure call him an absolute minimum. All right, look at f of b. That point b, is he the highest point of the graph? I didn't think so, but I did see that he was a relatively high point, so I called him a relative max. For point C, I saw that that was not the lowest point, but a relatively lower point, so I'm going to call him a relative or local minimum. For D, I noticed that he was the highest point of this graph, so I actually called him an absolute maximum. If I were giving you an in-person test, like originally planned, I would ask you to call him an absolute maximum. Now, WebAssign is going to call this both. It's going to call that point up there not only a relative maximum, but also an absolute maximum, which is kind of true, but the best answer for me would be an absolute maximum because it is the highest point, not just a relatively high point, it is an absolute maximum. But WebAssign is going to say both. So on your homework, when you see something like that, it's going to ask you to label it as a relative and an absolute maximum. Okay? All right, for point E, I called that a relative minimum because it is not the lowest point, it is just a relatively minimum point. I'm going to call him a relative or local minimum. Now I've added another point. I know that it wasn't labeled on there before, but I'm adding another point. Let's call it F. If this was my endpoint F, would you say that f of f, that last point there, is a relative extrema, an absolute extrema, or neither? Well, to me, he wasn't the highest point, so he's not an absolute maximum. I don't know what's happening on the other side of him, so I can't really say that he's a relative maximum. So that would be an example of a point on the graph that is neither a relative minimum or maximum or an absolute minimum or maximum. Because you don't know what's happening on the other side, those endpoints can really only be absolute extrema. They can never be relative extrema because I don't really know what's happening on the other side. So that would be an example of a neither. All right, look at example number 2 and 3 with me. These two examples actually weren't supposed to give you a picture. I've actually drawn the picture for you, but if I didn't give you a picture, you should have an idea of what they look like. So if I gave you the function x squared, hopefully we all know that it looks like a parabola. So I kind of drew a picture to visualize what was happening. And it asks us to find the extrema. I want to find the very highest point or the very lowest point. Well, because we know he's a parabola and his picture looks like this, I know that there is an absolute minimum down there at his vertex. So I can say that there's an absolute minimum at the point 0, 0. When does it happen? At 0. What is the value of the minimum? Would also be 0. When, remember, is x. What is the minimum? Would be the y, 0. What is the absolute maximum value? Well, because my parabola continues to go up, 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 up in both directions, we don't really have a maximum value because it continues to increase. So we would say that there is no absolute maximum or either relative maximum on this one because it continues to go up. Okay? Example number 3 gives us an x cubed graph. Again, they weren't going to give you a picture, so hopefully you know what the x cubed graph looks like. And so I drew it there for you. If I'm looking at this x cubed graph, where would be the absolute extrema, the absolute highest and absolute lowest point? Well, because my x cubed graph continues to go down and continues to go up in both directions, I can't say that there's actually any extrema. I have no relative or absolute minimum because it's going to continue to go down. I have no relative or absolute maximum because it's also going to continue to go up. And I don't really have any, can I call them humps? I don't really have any humps in between. So this one actually has no extrema. But the important thing is here, you have to have an idea